parallel lines. And I'm just going to blast right into an example. Again, it's possible they're going to give you these equations in a general form, but I'm going to use slope-intercept form because it's a lot easier to graph with that. So what I'm looking at are two lines here. One is y equals 2x plus 6, and the other is y equals 2x minus 1. Now let's get a picture and see about the different things we're going to ask you to find. So they both have a slope of 2, and this one has a y-intercept of 6. So 1, 2, 3, 4, 5, 6. And we'll do a 2 over 1, so a rise of 2 and a run of 1. So essentially that's the steepness there. There's our first line. The second line has the same steepness or slope, but it goes through a y value of negative 1. So up 2 and over 1. So that should look more or less parallel. Pardon my drawing, but gives us an idea. Okay, there are 3 basic things that are going to be asked that you can find when you're working with 2 parallel lines. The first thing that's going to be required is they're going to ask you for the vertical distance between the 2 lines. What they mean by that is if you take some point up here and you go straight down vertically to the other line, how far down is it? And there's a really easy way to do this. Take your y-intercepts and just say, well, that's vertical, so what's the distance? And so you can say, well, here we went up 6, and here we dropped down 1, so that's 6 and 1, a grand distance of 7. So that one's really pretty easy, the vertical distance. So that one's done. Horizontal distance is the next thing, and that has a little bit more work involved. With the horizontal distance, it's the same idea. You want to pick a point and figure out the straight across or horizontal distance to the other line. But which points do we use? Well, there's none that are easily identified off the graph. So we basically pick the next easiest thing to work with, and we try to figure out what these points are. These points are your x-intercepts, and what makes these easy to work with is that they both have y values of 0, because in order to be on the x-axis, they have to have a y value of 0. So what do? We go to each equation, we put in a y value of 0, and we solve for x. And that tells us what these x coordinates are. So let's do that. We've got 0 equals 2x plus 6, so we'll subtract 6. Divide by 2. Well, x turns out to be negative 3. Let's go to the other line now. Don't need this anymore. Again, we want a y replaced with 0, and we have 2x minus 1. So bring the 1 over. Divide by 2, 1/2. Okay. So, to get our horizontal distance, well, what have we done here? We've gone 3 to the left to get to negative 3, and here we've gone 1/2 to the right. So 3 and 1/2 gives us a grand total of 3.5, or for some of you, 3.5, whatever you prefer. Well, that's vertical distance and horizontal distance. And now you knew it. We're going to ask for the shortest distance between the 2 lines. Shortest distance, yes. Okay, let's clean up our drawing a little bit. Stuff we don't need anymore. Alright, shortest distance is going to be perpendicular from one line to the other. Okay, so we're talking 90 degrees, little segment from one line to the next. Now you have a choice here. Probably the easiest point to work from is this guy up here. The only reason it might be a little easier than, say, this one down here is because this one has all positive numbers, which is kind of nice. So we can take this point and say, well, let's take the point 0, 6, and figure out how far it is from 0, 6, straight across like that, to this other line. And if you think about it, what this means is, what we're trying to figure out is the same as our first example. We now have a point and a line, and we want to figure out the shortest distance between this point and this line. So we're back to basically what we did in the first example. Okay, let's get some room. Remember what we did in that first example. The first thing we had to do was figure out the equation of this line here. Now, with all the lines going on here, it can get very cluttered, so I'm going to try and keep it clear by putting in some labels. I'm going to call this guy here line 1, who's this guy. This guy here I'll call line 2. And this new guy here we'll call line 3. That way we can kind of keep clear which lines we're working with, because it can get really quite cluttered. So we're dealing with, we want a line that is perpendicular to lines 1 and 2. And that's what we're calling line 3. So let's figure out line 3. Well, it's easy to figure out most of this right off the bat. We know we want to be perpendicular to these two lines, so we want our slopes to be negative reciprocals, which means instead of a slope of 2, we want negative 1/2. So negative 1/2 is the slope we want. And here's the next easy job. Because we picked a point that's right on the y-axis up here, this line has a very easy to identify y-intercept. In fact, the y-intercept of line 3 is 6. So we don't even have to do any fancy algebra. Poof, there it is. We've got line 3's equation. Okay, so that's step 1. Step 2, we want to figure out the coordinates of that intersection point. Now that's the intersection point of lines 2 and 3. It's nothing to do with line 1. So we want to use lines 2 and lines 3. And that's why I've labeled them, because it is easy to get confused. So we're talking about the following equation. Now I can see I'm going to run out of some room here. So I'm going to erase this and start a little higher. What I'm going to do, I guess, is put, maybe we'll cram it down here. Line 3's equation looks like this. Y equals negative 1/2 x plus 6. Now I can get rid of this. Okay. So we want to deal with line 2 and line 3 and find the intersection point. Line 2, I didn't label them up here. So this is line 1 and this is line 2. Okay, now we're working well. We've got line 2, which is y equals 2x minus 1, and line 3, which is negative 1/2 x plus 6. I'm going to take the two right sides and equate them. So I'm going to go 2x minus 1 equals negative 1/2 x plus 6. What that's doing is I'm going to try and figure out the x coordinate of this intersection point. So let's multiply everything by 2 to get rid of fraction. That'll become negative x at 12. We'll add this x over to here, and we'll add 2 over to there. And oh, we're not getting nice even whole numbers. So what? That's okay. We can just go 14/5 or 14 divided by 5 if you prefer, which is 2.8. Now we have the x coordinate of this point, which is 2.8. And we want to figure out the y coordinate now. And it doesn't matter which line you go to. I'm going to choose line 2 because that doesn't have any fractions in it. So I'm going to go y equals 2 times the x, which we just figured out is 2.8 minus 1. And so that's going to give us y equals, this will be 5.6 minus 1, or y is 4.6. I'm just going to cram that in here, 4.6. Okay, we're ready for step 3, so I'm going to erase all this. And step 3 is to find the distance between these 2 points. And that is the shortest distance between the 2 parallel lines. Now remember, it's x from one of the points minus the other x. So we got 2.8 minus 0 squared. And then we do the same thing with the y values, 4.6 minus 6. And squared. Now, you could work this out, and I did, just bit by bit, and it would look like this. You're going to end up with 2.8 squared here, which is 7.84, plus, and then whatever we get here, it looks like negative 1.4 squared, and so that's 1.96. So you can write your answer if you add these up as the square root of 9.8, or you can throw all of this in your calculator and go ahead and work out a decimal approximation, which is quite fine for most of these applications, which is 3.13 as the shortest distance. And that is our look at shortest distances and vertical and horizontal distances between points and lines and parallel lines. So we'll catch you later.